Hello class, this is section 5.1 and we are going to discuss elementary row operations in this video. So this is going to be a linear algebra lesson, and those of you who are taking that other class concurrently may find this material a little familiar. So recall that from the previous video, to solve for an initial value problem, we need to solve this matrix equation where we have a n by n matrix X and we have a initial vector b1 to bn, and we need to solve for the constants. So we have c1, cn. So our goal is to solve for c1, c2, c3, c4, and cn. So as a first step, let's consider what it means. Let's write out the X matrix. And there you have it. So we just have an n by n matrix. We call the X, let X have coefficients a, I, j. And what happens now is that let's think about what this equation actually means. We can expand out this mess. What we have is that this matrix equation is actually an algebraic system of algebraic equations. And this is going to be a mess to solve. So our goal is going to be to rewrite XA so that it is upper triangular. And that means that we can write XA in terms of this. So we have A11, A12, A1n as usual, a 0 here, 2 zeros. So basically we want to write the matrix XA so that it is 0 everywhere under the main diagonal. So we have this main diagonal of A11, A22, A33, and to A and n. But we want our matrix X to be 0 everywhere underneath. So only the terms in the upper triangle are non-zero. And the reason that this is helpful is that if we have a matrix of this form, our equation is going to be like this. And this is a series of equations that we can solve because we can solve Cn equals Bn over A and n. And if we have Cn, we can solve Cn minus 1. If we have Cn minus 1, we can solve Cn minus 2, and we just cascade all the way up to solving all the C's this way. So our goal is going to write our matrix in this form, and there are some rules that we can use to try to do that. These rules are called the elementary row operations. And here they are. So the first rule is that we can multiply any row of XA, the matrix, by a constant. And that makes sense. I mean, if you have a system of equations like this, you can obviously multiply any of these equations by a constant and the equation will still be the same. Multiply by 2 or 3, it doesn't make a difference. The second rule is that we may interchange two rows of the matrix. Again, this makes sense when we look at the system of algebraic equations. The order of the equations doesn't matter. If I decide to put the second equation first and the first equation second, it shouldn't change our solution. And the third rule is that we may add or subtract one row with a constant multiple of another row. And this again should be something that you are used to in solving system of algebraic equations. We very often have to add two equations or subtract two equations, and this is just saying how to do this in the matrix form. This process isn't really as complicated as it looks like here. To make this a triangular matrix, we will go through an example in the next video. But I will say first that you should think a little bit about why these three rules make sense in terms of algebraic equations. And notice that none of these rules make sense for columns, only for rows. For instance, you wouldn't want to multiply just one column of this equation. It doesn't make sense that the solution will stay the same. So all these operations can only apply to rows, and a very common mistake is to try to do them for columns, but don't.